I work in the area of robotics applied to healthcare. I thought the best way to actually talk about what do I do is to show you some works that students have been doing in our lab, and I will be glad to answer questions. Let me just say before I forget, because I'm going to forget, we are looking for students that want to be involved in projects. We do have this requirement that we're looking for students that actually have very good programming skills. That sometimes is it's a filter, but if any of you feel that you are very good in programming, you have some experience in data science or machine learning, and robotics is even better, let me know, and based on your experience, we may be able to engage you in some of the projects. Okay, so I'm going to talk about the number of projects that we have, as I was saying, and I'm not going to show all the videos because definitively we don't have time for all the videos. Not all the videos work, okay? But what we try to do is to make healthcare more effective. We foremost look at the operating room and hospitals as the main scenario where we want to improve processes. If you have met today Professor Denny Yu, I don't remember. Yes, okay, so we share the lab, and there is some overlap between what we do. Denny is focusing more on the human factor side of processes and operations. I'm more in the side of computation and machine learning side. And so I'm production, he's human factors. But we actually do a number of things. We work together a lot because we both are interested in the operating room. So this is a system that we have developed several years ago, before the Kinect was in the market, before the Kinect was out at all. There was this need of keeping the operating room totally sterile, and surgeons were using the keyboard, or nurses were using the keyboard, and they found that this causes the spread of bacteria. So they came to us with the request of developing a touchless system where they can move the hands, similar to gaming technologies that you're aware of. You can move your hands and interact with MRI, medical records and MRI images through electronic records. You can manipulate the image, you can rotate the image, you can retrieve the images, you can do a number of things from the station where the surgeon is without the need of moving. So this is how it looked. Originally, the system was developed for the office of the doctor, of the MD. The system worked so well that then we asked the question whether we can take this to the operating room and try that. And at some point, we actually tried that. This was the first time in the world that a touchless system, a touchless interface was tried in the operating room in a real surgery. This is a brain biopsy. What you see here, you don't see the patient is on the side, but this was the first time that such a system was actually tried. And the work started a little before I joined Purdue. That was a while ago, long ago, and then we did improve the system with the students here, and we applied that also to veterinary school as well. All right, let me talk about other things. So we look into our students and we said, okay, what else can we do that involves technology, robotics, and the operating room? What are other type of processes that we would like to improve? Another interesting project was this idea of having a robotic scriveners, basically a robot that works together with the surgeon and delivers surgical instrument as required. So as you know, the surgeon is operating, needs all the time instruments. Usually we have a surgical technician that delivers the instruments. The idea was, can we use a robot to do that job? The robot needs to understand spoken language. The robot needs to understand signals, hand signals. And the robot needs to be able to predict also what is the intention of the surgeon. Okay, so we did a lot of work on this. We have with an initial prototype that the robot was extremely bulky initially. I'm going to see a video of that robot. Was kind of bulky. You see the surgeon, for example, using this sign for scissors, and the robot would actually deliver the instrument as required. So this is how we had the first prototype with an industrial robot that you cannot really put an industrial robot in the operating room because it's kind of risky. But the first prototype actually worked with an industrial robot. And as you see, the person is actually simulating surgery. This is a simulator, and working together with a robot and getting the instruments. Okay, as I said, there's so many things that I'm not going to go one by one, but just I want to say a few things about each of these works. Then this was covered in the TV, in one of the programs in the TV, in the US TV, national TV. And as you see, we move into other prototypes using the same idea. We move into dual-arm robot. This is the Baxter Robot. The Baxter Robot is a dual-arm robot. And we look into challenges where we can also hold or grasp sponges, for example, or gas. So things that are maybe flexible, non-rigid, how we can deal with that. See, this is another type of robot. So we had a lot of work in this type of system, and we extended in different directions, okay? There was a lot of questions, how you pick instruments when they're cluttered, really in the operating room. This is how they look. Humans are very good on dealing with these ambiguous scenarios. Robots are not as good. So that was the subject of another student that actually recently finished as of a month ago, which applied machine learning. Again, I'm not going to get into boring details at this point, but he realized that scrub nurses are very good in predicting the need of the surgeons. We call them mind readers. They can look at the surgeon and they can predict. And we wonder whether robots will be able to predict as well, not only based on the process or the procedure of the surgery, but also based on what they are thinking. So what we did is we mounted these surgeons with EEGs, portable EEGs, wireless, another type of sensors. As you can see, pass me the scissors, read my mind, nurse. And we tried to obtain patterns from EEG signals, and we actually collected a number of multimodal signals, all from the surgeon. We also collected muscular activity on the arm, orientation, gaze orientation, face position, signals, brain signals, all these. We combined these, this was the work of Tian, combine those in a meaningful manner, and the idea was to predict the next instrument when there is a need for predicting instruments. This is the last project that I'm going to talk about because I have to pick and choose something that is enough. So this is the STAR project that is, we have another year, a little bit less than a year for this project. The idea is telementoring, if you're aware, is the idea that you can have an expert providing surgical expertise to a medic that is in the battlefield or in a rural region and doesn't have the expertise required to deal with the condition at the moment. So the idea is, what is the best way to deliver this surgical expertise? And we are looking into technologies as mixed reality, augmented reality, smart glasses, and so on and so forth, okay? Here you are going to have a glimpse of the initial. This was the concept video that we created for the sponsor when we start working.
We can contact our mentor stateside.
Hello, this is Dr. M. How can I help? My patient was caught in a blast. His shin is swelling, and he seems to be in danger of developing compartment syndrome. We need to do a fasciotomy. Don't worry, I'll walk you through it.
He's ready for surgery.
Send me the data.
Okay, so this was the first prototype using a tablet. You're going to see this is the concept that we created initially, where you have the mentor station. The mentor station doesn't have to be sterile because it's far away, and they have a projection of the image of the patient. And then you have the trainee or mentee, okay, depends how you call it. That could be the battlefield, all could be located all together in a different unit, different hospital, a different country. First step, the first prototype had a tablet, and the trainee looked into the tablet as if they were looking into a window, through a window. And on top of the tablet, there were annotations. These are the annotations that represent the operations that he needs to follow coming from the expert, okay? So this first prototype was tested in IU School of Medicine in a course that they ran called ATOM, Trauma Operative Management course, that they ran with porcine models, okay, with pigs. That after this is something that is regardless of our technology. They run this course every year, and in the end, the porcine models are euthanized. So we got a lot of formative experience. We moved. This is some videos of that experience with the first prototype, where, as you can see, we were using tablets. We have our expert mentor in one room, and we have the mentee in a different room. Since this was already about 4 years ago, first prototype, the mentee is seeing the surgery through the tablet, okay? And is receiving instructions directly. Then we move into an additional scenario of surgery where we look into a procedure called fasciotomy, and we look into different scenarios. For example, what happens when there is only one mentor? What happens when you put several mentors together? Because you may have what is called polytrauma. You may have injuries that require the expertise of multiple experts, which is really unlikely to occur in the battlefield, that you get all these experts, right? But through this telementoring procedure, we can actually allow people to work together to save the life of the patient, okay? This is not working, but again, we have some coverage. Well, maybe now. See, I was, at this point, I did right there. Let's see here.
This morning, a research project at Purdue with potential life-saving effects. Students and professors from several different departments are coming up with new technology that
Come on.
military surgeons on the battlefield. So we went inside the lab to find out exactly how it works. In troops are hurt, they're rushed in for treatment. When every second counts.
So the system here is the training system.
Several different prototypes use robotics, use a robot to hold the tablet and to help the trainee to guide the tablet as they were operating.
A lot of the combat medics have a good amount of training, but maybe
This is the lab.
refreshed recently on how to do a particular kind of operation, or they haven't been trained hands-on for certain kinds of trauma injuries.
So Anderson and a handful of other men
Okay.
a mentoring system.
You have this tablet right here in front of my face, and the training would be
Let me show you a little bit because we don't have much time. Okay, another thing that we provide with this system is future step visualization. So this is relying on the fact that there is communication between the mentor and the trainee. What happens if there is disruptions in communication because we are in actually what is called an austere environment? Means it's the battlefield. Maybe the communication gets disrupted. Maybe the enemy is disrupting communication in purpose. So we had this great thoughts or great question about whether it will be awesome if the system, the portable system that the trainee or the mentee is using can rely on some form of autonomy, some form of artificial intelligence that the system will know alone how to mentor the trainee during procedure if there are gaps in communication. And we did work in that. I mean, what you see here is our system dealing with what is called a cryotomy, where you perform a cryo, you open the airways for oxygen, and this worked pretty well for this specific application. So we have that specific feature available. And I don't know what we have here. This another one. Okay, whatever. Yes. One of them, internal anatomy. So, of course, then the next question was, you know, the tablets have the problem of encumbering the way, being in the way of the surgeon, right? So we move into using technologies like HoloLens. And we saw not only that we can actually receive instructions, but we can also, by looking at the patient and looking at the injury, may be able to create some form of X-ray of the patient. It's not accurate, it's an approximation of the anatomy of the patient in real time, so the mentee can actually operate as he sees what is going on in the internal organs of the casualty. Okay? All right, just to finalize, last one, let me close this. So the last version of the system as for today, this is an effort of 5 years total, okay? We are right now running clinical tests, clinical experiments. In only 2 or 3 weeks, we have actually the second clinical experiment. The first one was with cadavers. Now we have another experiment with simulation. And the system is much more advanced at this point, just to give you a glance of where we are. So all what you saw so far is what is called a control setting operating room. Now you're going to see is really the austere setting, the battlefield. This is not the battlefield, but this is really outdoors, not control environment. We're using the HoloLens now. This is the mentor station. All this is working in real time. We have a simulator, as you see. This simulator can actually breathe and bleed. Okay, it's fully functional.
Visualization obtained from the headset is streamed to the mentor side, who can visualize what the medic is seeing.
And here you see the expert really using tools. Now, what happened is that the view of the HoloLens may not be fixed. So we have another camera that is coming from a drone that is hovering on top of the patient and delivering images. And of course, what we want is really zoom in on the patient.
Routines are applied to the first-person visualization feed from the operating field. These stabilization routines eliminate sudden shifts in the mentor.
So you see that the mentee is actually moving the head, but the view remains fixed. So there is here nice algorithms that the students actually came up with.
Instructions over the stabilized view from the operating field. Thanks to the augmented reality head-mounted.
And this augmented reality, you can add virtual instruments. Okay, so all right.
3D object projected onto the patient's
I'm
body.
going to finish this. Okay, to conclude, there's some work that we are doing with Denny in the area with Professor Yu, in the area of using the Da Vinci system. You know what? We don't need sound, so it's okay. So we are lucky enough. We run a lot of experiments with the Da Vinci, and we are lucky enough to actually have a Da Vinci here in Grissom Hall. If you want to see a Da Vinci, it's standing on the 2nd floor. Okay, room. Do you remember the Do you remember the room number? So pick 2nd floor on the elevator. As soon as you came out from the elevator, look at your right. You're going to see the first Da Vinci in the whole campus at Purdue. It's not the first Da Vinci in Indiana, but it's the first Da Vinci robot at Purdue University, and it's part of our systems, our work. It's not located in our lab because there is no more room in our lab, so we have to resort to use this building, Grissom. And right now, in the next few months, we're going to actually start working together with Surgical Intuitive on the area of autonomous surgery. So this is an area that we are very interested as well. Okay, all right, this is so far my students' work and my work as well, my team, my group. And I will be glad to talk to you if you're interested in participating as we